What's up, everybody? Sparrow with a Gun here from Sleepless Nights with another episode on Space Engineers Programming 101. In this episode, we are starting a new script that we're going to work on. And this might look familiar. Oh, yep, freak out. This might look familiar to some of you that watch my survival Let's Play, or more my Let's Play at the moment. It's not really survival at the moment. As this is a rotating reactor type system, right? So what I wanted to do, I've always liked this idea, and I'm trying to implement it in my current Let's Play, but I figured it would be a win-win. I need it for my new ship, and we can code it here. So basically what I wanted to do is spin the reactor based on power input, right? So this one shouldn't be as complicated as our last couple have been, like with the solar panel adjustments and all that kind of stuff, in theory, but it rarely works the way theories go. So I've named what I've got here, this is our reactor thing. So we got our large reactor, the two reactor lights. This is more for future planning if we wanted to have them turn red if the power was low, something like that. And the reactor advanced rotor that it's sitting on. This is going to come into play as we're going to have to adjust it to make it spin and all that kind of stuff. Okay, so I've got this, our basic code set up where we've got globals and all that kind of stuff. So the first thing we need is the rotor. So let's do, what is it, rotor stator, I think? Maybe? And we'll call this rotor. My reactor. We'll call this reactor. Simple enough. Interior light. And we'll call this L1. And then we'll just copy and paste if I can. There we go. I don't always really like this text editor that they've got set up. I know it's basic at the moment and not their overall. Okay. My rotor. I thought it was stator. Let me check this. Alright, so it's actually motor is the problem. It needs to be motor, not rotor. So it's motor stator. I also found there's an advanced. So because we're using an advanced rotor, I figured we'll go ahead and name it advanced. I don't know if there's any advantage to doing that for what we want to do with it. We will have to see. Okay, so first thing, we need to instantiate these. So let's say rotor equals grid terminal system. Get block. We'll go by name. It's more precise that way, in my opinion. With name as my motor. That's so weird. It's probably because they originally were called motors, and in the code it was never changed, is probably what happened. And I'm going to highlight this part so I don't have to type it again. Reactor equals as my reactor. L1. Oops. Interior light. And this part will actually just copy the whole thing. And then we just need to change to and fill these in. Oh. Block with... Oh. Ha 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 ha. That's a capital I. That's not going to work. Alright, how about now? Aha! Success! Okay, so we need reactor advanced rotor, reactor light 1 and 2, and large reactor. So reactor advanced rotor. And you can basically change this to whatever you actually want it to be in your own world. If you don't like these names to identify stuff, you can just change the names and then change it in here. Which is fine. Everything else should work right, and you'll be able to adjust it accordingly. Now, There is another way we could try and do this, and we might want to do it so that it's less work for the rest of everybody using the code. So what we're going to do is comment this out for now with the double slash so that the compiler doesn't run it. And I'm going to try something a little different, but I want to look it up and actually look through how it's done. So give me just a second and we'll come back and do that. Alrighty, so this is more for my own sake of coding, so that it doesn't make it that hard on everybody else to do. You'd be able to just plug it in and go. So this is how we normally do things, where we go by name, which is doable, but it requires that everybody that uses the code go through and actually name everything exactly the way it's supposed to, or go into the code and change each name. It's doable. It's doable. But for now, we're actually going to remove this because it's just commented out anyway. And you'll notice we're leaving here a method called startup, and then it goes right to main code. Startup is down here. So what I did was, first off, we set up our display, which, again, I did use as the name, because I always have this. We don't need a display for this code. I'm using it for debugging, so this will get ripped out whenever this actually is finished. Then we have a line that says loop through reactor group and instantiate variables. So what we've got here is a reactor group. And when you click on it, it says reactor advanced rotor, reactor light 1 and 2, and large reactor. Okay? Good. Now, so basically what you can do is you can add those three things and then just add it to a group that's called reactor group. And that way you only have to name one thing. What that does is, instead of having to instantiate another variable, I use the grid terminal system to my advantage. So basically we've got a loop here that says standard loop a counter of I equals 0, blah, blah, blah. If I is less than grid terminal system dot block groups. So this is how you would access the block group. So if you have different groups, you would basically say, just let me just type it in right here on this line. So basically what you would do is say list I my block group. And then you could call this groups, for example, equals new list I my block group. Then what you would do is say groups equals grid terminal system dot block groups. And this would add a list of all the block groups, all of those things. Like we have one that's reactor group, but you could name it a bunch of different things and it would go into groups, and then you can loop through it and find the group that you're looking for. Found this out relatively recently and it's come in handy like this. So what this is doing is it loops through all the different block groups, if there's more than one, by going by the count of the groups. Then within this loop it says if grid terminal system block groups at index of I, so if there's more than one, it's 0, 1, 2, 3, etc. dot name, which returns the string, which is the name of the group, is equal to reactor group, which is what we're looking for. Then it breaks into this other area. So then we go into another loop, which is right here. Now this is where things get a little bit dicey to read, but this part isn't really for reading. This is just something that would run. I'm just explaining it. So it goes, we set up a new variable. This is hard to see, but it's actually a J. It could look like an I there, but I, J, and then I think K is usually the just standard programming that you use when you're embedding loops. So J equals 0, this could be whatever you wanted as long as it doesn't conflict with any other variables. While J is less than grid terminal system dot block groups. Now this is very important. This is still using I, because we still want this block group. So the J is for the blocks within the block group. I is still going to hold the block group that we actually want to work with. So block groups at I dot blocks dot count. So how many blocks are in the block group of reactor group? Okay. So then what we do is if grid terminal system dot block groups at I, which is again reactor group if this has been triggered, dot blocks at J. So the index 0 through however many blocks are in the group, dot block definition toString contains motor. Now, this is where things get a little bit confusing. So let's type in a new line here, and we'll do... so the variables are instantiated now. So let's do display write public text, and let's use the React. No, we'll use the lights. We'll use L1. So L1 dot. I wonder if this will work. Block definition dot toString, and toString will convert anything to a string if it can, and then we'll want it to add on as well, and let's give it a couple new lines. So let's check that. Hopefully it'll run. Yes, awesome. So we'll remember it out, and then we'll run it. So this is what block definition looks like. My object builder underscore interior light slash small light. It's a backdoor kind of thing as to the underlying code as to what it uses to identify things. It's another identification system. So what you can do there is when you convert it to a string, you can say if it contains light, for example, then it will say, yep, it contains light. So this is a very definitive way of, tell you what we'll do. We'll actually add, oh, and I put false. What a dummy. I need it to append, so I need it to be true. Let's do new line, and then let's do, just for example, we'll do them all. Block definition dot toString, and how do I want to do this? Copy. Let's see if I've got room. I'm gonna cut down on the spacing reactor, and then I'm gonna paste that in. See if that works. Awesome. And then we'll run. Alright, so we've got the names up there: Reactor Advanced Rotor, Large Reactor, Reactor Light 1 and 2. But then you can see down here we've got Interior Light Small, Motor Advanced Stator / Large Advanced, Reactor / Large Block, Large Generator. So again, it's not really important, but it's another means of identifying without trying to use names or a quick way to get to data type and things like that. There's a couple other ways you could do this too. You could, in theory, actually use getType, I believe, and this is actually a function. And I will show you what this returns to, because theoretically, I think you could actually use this, to be honest. Again, you'd have to be pretty precise about it, but we're kind of doing the same thing. So this is the getType command. It's sandbox, game, entities, cube, my interior light, my advanced motor stator, my reactor. So this might be a bit more precise. So what we could do, you're not going to see anything different here, because it's essentially going to do the same thing. But what we could do is say, instead of block definition, we could say getType. And then instead of contains motor, you could do the full my motor advanced stator. Now, theoretically, if all this works right, you shouldn't see a single difference. Okay. I screwed up. Oh, wait, maybe it's the toString, because it's already a string. Maybe? Contains takes one argument. That's okay. That is one argument. Alright, so not doing that. Let's back that up. What about if we just do motor? I wonder if it's the advanced rotor stator thing that I messed up. New line in constant. What? What are you talking about? You talking about game? Alright. So let's change this back, because it's screwing things up. ToString contains... Oh, right. That could be part of it. There we go. I had taken out one of the quote marks. Okay, so theoretically, no difference. Reactor, advanced, rotor, it still got it. So you could do either one. I particularly am going to use block definition, mostly because it's not a function call. Oh, come on. I don't like doing a ton of function calls if I can help it for something like this. Anyways, so what this does is it says grid terminal system, block groups at reactor group, within the amount of blocks that you have. Currently we're on J. Block definition, turn it to a string. If it contains motor, then we do the standard rotor equals grid terminal system at block groups I, block groups J, as I my motor advanced stator, excuse me. So I hope that makes sense. And then we just do else if it's got reactor in it, well, make it a reactor. If now this one's a little tricky. Both the lights are considered a light. So unless you want to have a permanent name, you have to work with it. So what I ended up doing was L1, if it doesn't contain, this all basically says if it doesn't contain light 2, and if this doesn't, or if this does, so if it doesn't contain light 2, but it's not one of these two, it's the first light, which is what we did there. And if it does contain light 2, then it's the second light. Pretty simple. The only caveat to this that I want to try is placing down an unedited rotor, reactor, and light. The reason for this is I want to check what it defaults the names to. Okay, so light does have a capital L, so we could still use it. You would have to change the number if you place it down. It couldn't just be in the group, I don't think. There's probably a way around that, but I don't want to work with it right now. And it's got rotor in it, so everything but the lights. The lights would be a little bit more work if I wanted it to be able to, you just place it down anywhere and it works. Alright, so that's the setup command. Basically we don't need this anymore, it's just going to run. So when we start up the code, it's just going to start everything up, and then all we have right now is displaying the stuff. But what I want to display is something else. What I want to display is two things. First, we need the rotors, or not the rotor, reactors, detailed info, and we'll make a new line. And actually, we'll make two. Let's separate it a little bit. Then I want something a little different. Now, rotor, if I do detailed info, we can show this off just for a second. The problem with rotors, now I'm also going to activate the timer that we've always had set up in this world. We don't need those lights anymore. So the timer, again, if you haven't seen my previous episodes, is set up to run the program and then trigger itself again. It keeps it looping at a 1-second interval. And then I have a button here set up to trigger the timer block, which will run it and just loop, and that way it's constantly doing things. So when we click this button, you'll see this change. Bloop. Now you'll notice we've got the large reactor has max output, current output, yada yada yada. But it has no rotor detail, because the rotors don't give off detail. So how do we know what the rotor's current RPMs are, or speed, and stuff like that? So what we need to do in here is not call for detailed info. What we actually want to call for is the velocity member. I think it's called a member. Value, item, whatever. I don't remember what it is. So there you'll see the velocity is equal to 0. Okay? So we have an easy way to get the velocity. That's easy enough. And I'm pretty sure, let's go ahead and turn the rotor off for a second so we can play around with it. I'm pretty sure it's always measured in RPMs. And the max is 30 RPMs. Okay? So what we need to do is I want this percentage based, basically. So I'm going to declare above display, because display is going to be gone when we actually want to do this. I'm going to declare 2 float values and call it reactor max. And we'll start it off at 0 for now because I need to check it, and then rotor max. And this we can set to 30 because we just saw that it's 30 RPMs. Okay. Oops, yes, I want to remember the changes. Okay, so the max output of a large reactor is 100 megawatts, which a megawatt is 1,000 kilowatts, I believe? Maybe? So we're going to set this... oh, goodness, what's 100 times 1,000? Blah. A million? No. A million would be... well... This is easy enough. We've got a computer right here. So check this out. We're going to go... we're going to colon that out so we don't need it. And then for this part, we're just going to put what is 100 times 1,000. We'll turn this into our own little quick calculator. Alright, so... Wow! I must be tired. It's 100 freaking thousand. How did I not know that? Wow! I'm definitely tired. Yeah. 100 times 1,000, I wonder what it is. Alright, so 1, 1, 2, 1, 2, 3. 100,000. Now, this will need to change depending on the reactor used. I'm using a large one because a small reactor spinning wouldn't really make a whole lot of sense in my opinion. But also mods. The mods that I'm using, like in my current Let's Play, for example, it does, gosh, it does something like, I think it does something like gigawatts or whatever, like 20 gigawatts. So it's like 20 million instead of 100,000. So you have to take that into account because it's going to affect the overall percentage. Though, I take that back. There might be a way to actually calculate this. What we're going to do for now is do that, and then we'll make a new line that says float reactor max equals, and we're just going to zero it out for now. Because I think there might actually be a way to factor this out. We'll have the value anyway. Okay, so we'll leave startup down there. We already know how to get rotor velocity. That's easy. So, what we need to do is make a new variable, or a new function, and call it, let's call it get rotation, or set rotation. That's a good one. There we go. Set rotation. So this is going to be a lot of string manipulation. So what we need to do is declare a string and say react, or no, let's do, yeah, let's do reactor details, and it's going to equal reactor.detailed info, obviously. Now what we're going to do is create a variable, or you can do it actually as a string array if you know what you're going to do. You can put in var there and it'll just figure it out. And we'll call this react temp equals reactor details dot split. And then we're going to say split by empty spaces. And what this is going to do is it's going to populate this array based on every time there's a split in this string. Now, actually, I take this back. We don't really need to do this. We can say dot detailed info dot split, and we can skip this entire thing here. Save us some space. Okay, so we've split it. We have all of the pieces of the detail broken down into stuff. Now, the trick... Now, we only have to do this one time. We don't need to leave the code this way. That's kind of important. So, what we're going to do, and since display is a global variable, we don't need this. We can comment this out. And we can just call set rotation right here. And then from here, what we want to do is do a for loop. int I equals 0, like standard. I is less than reactTemp.count. No, length. The string arrays use length. Arrays use length, lists use count, I believe. We'll find out in a second if it breaks on me. And we'll do display.write public text. reactTemp at I dot toString, just in case it's seeing it as a different value. And then what I want to do is make a colon so that we have a separation, and actually input I, what array number, or what index number we're at within the array. And let's say true. Close that. Now, before we do this, let's go ahead and put display write public text and just do a blank and say no appending so that it clears it before it calls this, so that we can loop through it and get all the info. Now, this is going to change. This is... what is this? The best overloaded method, line 30, the name... oh, does help if you spell things right. Line 30. Where's 30? Ah, here we go. Okay, let's try a toString. It should have worked. The best overloaded method... oh, wait, no. It's because split uses a character value, and the double quotes imply a string value, so single quotes or apostrophes should fix it. Alright, cool. So now when we look at our screen, if we run this, okay... oh, crap, I didn't do new lines. That helps. So after I, what we want to do is do a new line. Alright, that should clean it up. There we go. Alright, so we've got type large reactor max is at reactor max. Wait. Okay, max is an index of 2. The number is 4. So 2, 4, 5, 7, and 8. So what I'm going to do here is change this from a loop, and what we're going to call is this part. Actually, let's change this to like this, and we're going to copy this whole thing. Actually, let me put... yeah, there we go. Let's copy this whole thing. And we need 2, 4. There's a way to crap. There's a way to do a new line break, and I don't remember how to do it. Let me do this part. Well, no. There's got to be a better way to do this. So... oh, I know what to do. I know what to do. We'll do just single lines. Like this. And then 2 here. And we'll copy this, and it's 2, 4, 5, 7, and 8. And this will let us figure out exactly what we need data-wise. Or it should, at least. Alright, so reactor max 100. So that's 2, 4, 5, 7. So we clearly have multiple lines in here somewhere. So what we're going to do is comment out a couple of these, like this one, and maybe this one. And see what we're left with, because somewhere in here it's splicing strings. Okay, so for example, we kept the 100, we kept the 585, and the kilowatts, but we lose the megawatts, which is somewhat important if we're going to actually calculate this legitimately. And I believe that was 2. Yes. So reactor max. Oh wait, no. We don't need 2. We don't need to know the reactor max. What was it though? 4 is the number, so it must be 5. But 5 had a lot in it then. So 5 holds megawatts and current. Ah, okay. That's the problem. So what we want to do is basically split 5, or we could do a remove, I suppose. But basically what we're trying to do here is isolate what we actually need to store. So, for example, we're going to do string, or actually, let's just do a comment, and then we can do it later. So let's say 2 equals, or not 2, 4 equals max power, 5 equals max ID, like identifier, for what measurement it's in. 7 equals current power, and 8 equals current ID. And this will help us to basically separate them all out for what we need to do. Now, with 5, let's work with 5 for a second here. We know the other ones work perfectly fine. So that's how we want to leave this. So we have megawatts and current. We need to get rid of the current thing. So what we could do is say... we could say 5 substring... or no, we'll do a remove. So let's do remove, and we'll do... react temp 5 again. So basically we're doing a string within a string. We're saying this string, which is the megawatts and current, we want to remove, and then parentheses, and then from the same string we want to do index of current, I think, and then close that both out, I think. Let's see if that works. Yes, so we're left with megawatts. Alright, cool. So what we want to do here is we want to create a new string. So we split it up. Now we want to do string, we'll say power data equals react temp. And let me go ahead and copy this because we're going to be using it a lot. Oh, and we'll do our own little stuff here. So max power plus react temp. Which one is it? 4. I don't know if we actually need the 2-string part or not, so I'm just going to leave it. and then do react temp. I'm wondering if we should actually... Nah. I was wondering if we should actually put all of this in a string of its own, but I think I'm going to try and leave it this way. And then we'll do... let's close that for now. And then power data plus equals new line. We'll leave the quote open and say current power plus 7 and space plus and 8. And then we'll also add a new line to the end of this, just because. And then we'll do string, yeah. So let's do, we've already got the display thing here, so we might as well use it. So let's say power data plus, since we already have the new line there, let's add another new line just because. And we'll do rotor dot velocity. Oh, let's actually fancy this up a bit. Rotor velocity, current RPMs with a colon, and then add that in. No problems. Alright, so that works. We've got what we need there. Okay, now I do think I might store some of these variables actually, because we might need to use them specifically later. Now, one other thing I want to try here before we change all this code up is I want to put index of new line current, because I feel like there's a new line character return in that block somewhere. There is, okay, because it didn't yield an error. So, what I want to do is say, tell you what, we're going to change this up. Instead of doing this all in one string, we're going to do string max power equals, and we don't need all this fancy stuff. I was just doing that for displaying purposes. Well, we can leave it. Well, we can kind of leave that actually. That's not a big deal. And we'll do string current power, like so. And we'll get rid of this because I'd like to keep it kind of even across the board. And for now, let's change this to like this. I don't think I really need to get rid of all that, actually. Current power plus new line, rotor current RPMs. Oh, with a colon and a space. There we go. So nothing should really change, but we've separated the data a bit so that we can more properly analyze it. So, what I need to do here now is, instead of displaying the data, let's also add a second new line there. Instead of displaying it, we need to calculate with it. So, what I need to do is say, let's do... Alright, so what I need to do is say, actually, we don't truly need these, because we have all the data we need to work with here. I tell you what, here's what we're going to do. We're going to keep this stuff so that we can keep displaying it. But I am going to actually clean some of this up. So first of all, let's clean up this one. Reactor temp 5 equals... we're going to do this here. Let's copy you, and then we can actually get rid of this. I know I'm moving stuff around a lot and kind of repeating stuff, but it's because I'm coding this live, so it causes some stuff. So let's see if this works. If this still yields the data, then we're fine. Need a semicolon there. It might yield, like, nothing. I'm not sure. Nope, it's still giving us megawatts. Sweet. Alright, so we basically just cleaned that up to where we can just access this one now, and it's fine. So, what we're going to do now is now we actually get to the heart of calculating things. So, let's call this calculate power. And then we're also going to need setup rotor, but that will come later. Come on, I hate that. There we go. Alright, so calculating power. What we need to do is say we need a switch case. So I'm going to do switch react temp. There we go. 5. Okay, it should be fine. I was going to do a 2-string, but I don't think it needs it. Now, what we want to do is a case where it's equal to megawatts. And we'll do a break line. Now, this is purely just on the off chance you're using like a mod, or a modded one. Let's also do kilowatts. And we'll do just on the off case. It's not even really possible, but just because if you were using some kind of mod that was a tiny reactor and it put out in mod, I don't know. No, we're not going to need watts. We're not even going to need kilowatts. So let's just work with what we need. So we need to convert it down to kilowatts. And no, actually, it needs to be converted to watts. Now that I think about it. Okay then. So let's do... We're also going to need 2 more values. We're going to need a float for max power in watts, which equals 00F. Now, I believe, if my memory serves, that megawatts to watts is 100,000? Maybe? In case anyone was wondering, I'm actually looking it up right now. 1,000,000. Okay, so megawatt is 1,000,000 watts. So if it's equal to megawatts, then we want max pow W to equal react temp. What's the actual one? 4? Yeah, it holds the actual power. Now, here's the fun part. We have to use a float parse to turn it into a number instead of a string. Multiply that by 1,000,000. And that will give us the watts in, or the max power in watts. Now, ooh, goodness, gigawatts. Who knows? 1 billion or something? Actually, yeah, I think it is 1 billion. So, in that case, max pow in watts equals float parse react temp 4 times, okay, this is going to be 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oops, one of those was a dot. That's not going to work. There we go. Gosh, that's a lot of power. And of course, kilowatts is equal to... Let's just go ahead and add that, just because it makes me feel better. Kilowatts... I like feeling like I have every angle covered and it's not going to break on me if somebody I loaded a mod that runs some kind of reactor in watts and it won't work, you know. I don't know. And then multiply it by 1,000, I think. Right? Because 1,000... Yeah. Yeah, that should be right. 1,000, million, billion. Yeah, that makes sense. And if it was in watts, we wouldn't need to do anything. So, max power is now a float value that's been set. And let's do float kerpow watt equals 00f. Okay. So now we need basically the same idea. Because what we're really trying to do here... which one is current power? 7. No. I need the ID, so 8. Okay. And what we're really trying to do here is make a common ground, make sure that both of the calculations are set between the current power and the maximum power, because if you have megawatts and kilowatts and whatever, it causes a bit of a issue. Now, what we could do is we could have actually set this up to do the calculation in one thing. Not a bad idea. The only problem is it gets confusing and the code gets very cluttered, and so I'm doing it this way to make it easier to understand, so that you can actually... I did that wrong. Whoa, what the... What is happening here? What are we doing? Okay. What just happened? It, like, reset the whole entire thing. What in the world? Alright, hold on a minute. Alrighty, we got it. So, you'll see the power percentage up here says 0.18% and the current rotor RPMs is 0.18. So, we have gotten down what we needed to. So what it's going to do, I took the time to actually, like, alter the code and everything so it looks better, and I figured everything out and I know it works. So, here's the thing, we have our switch statements that we went over before. I put them back in after it weirdly just cut it out. So, float power percentage here, what we did is we said current... Wait a minute, what did I do there? Velocity... Oh, I see. I meant to do that up here. Okay, so what I want to do is current power in watts needs to be divided by the max power to get a percentage, which in this case is 0.18. But what I want to do is it's 0.17553, something ridiculous. So I'd like to just round it to the nearest decimal. So what we're going to do is, this is a float, so we can't return this as a string. So what we need to do is parse what we're going to turn into a string. So we're going to parse this. Now, actually, I'm not going to do it on both ends. And we're going to need another parentheses there because this calculation right here needs to be in its own calculation. Then we're going to make it a toString and put it as N2. Now this means numerical 2 points, if my memory serves me right, number 2 points. So it just makes it down to 2 decimal points. It'll round it up, or down, or whatever, depending on what it needs to do. Now we're going to close that parentheses so that it parses this after it's converted it to a string and clamped it, and then it'll turn it back to a float, put it in the power percentage. Now in that case we don't need to do this. I put this in the wrong place. Oops. So, that's all we need for power. We calculate the max, we calculate the current, and then we make a percentage off of what we need. Then what we do is we turn the rotor off, which we've seen the on-off command before, set the value of braking torque. Again, I don't know if this is perfect or not, but I found that if you put 336 with 1, 2, 3, 4, 5 zeros, it makes it maxed out. Whether or not that's the exact number, I don't really know. One way to find out would be to do this and see if it's 334. We'll check that in a second. Then we make velocity percentage, which is equal to rotor maximum multiplied by the percentage. So in this case, you're taking the maximum rotor speed, which is 30 RPMs, and multiplying it by 0.18%, which makes it whatever. It's like 18% of 30. And then we set the value of velocity to a float, which is velocity percentage, or vel percentage. And then this stuff is just for the string. I did add in here, I did a double space, and then power percentage, vel percentage to string. We don't necessarily need that. I don't think. Let's try it without it. We need the to string, but we don't need the numerical to, I don't think. We'll see what that does. And then I added the percentage sign, and then it does the rest of the RPMs. So pretty simple. So let's check that. It should run fine. Let's see what it does. Now this says 0.3. That's... that's interesting. Okay, that's weird. It was 0.18 before I did that calculation up here. I'm wondering if that's causing a problem. Let's take this out and see what it comes up with on its own. So let's just not screw with percentages and whatnots and see what happens. Yeah, 0.175. I wonder why it went to 0.3 when I did that. That's weird, especially when I told it to go to 2 decimal points. Whatever. So anyways, as you can see, the RPMs are setting... They should be setting properly. I hope they're setting properly. That seems a little bit exact from a maximum of 100,000 watts, or 1,000,000 watts, to 30 RPMs. That seems weird. I'm suspicious. I am suspicious. Well, we could do our own calculations, actually. So we've got basically 1,000,000. So let's do 585,000 divided by 1,000,000. Oops, I think. Wait a minute. Is that... I don't think that's right. Hold on a minute. Okay, so as it turns out, I think it actually is right. I don't think I was calculating or showing the numbers correctly. So, right under current power, we can see how it converted it to where the top one is the max at 100 million. The second one is the current, which is 585,000. So the power percentage is what we weren't actually seeing. So if you divide 585,010 divided by 100 million, you get 0.005 blah 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 blah. It's when you multiply that by 30, which is the maximum RPMs, that we get 0.17. So the current rotor RPMs are actually set correctly, we just weren't seeing it properly. So with that in mind, we have one final piece of code to add. I did break this up just a hair, because if it's past the plus sign, you're basically allowed to break it up and it's okay, I guess. I forgot how some of that worked. Some things you can get away with, some things you can't. So I broke this up so it's a little easier to see. Actually, what we can do, and what's typical, is to basically tab this over until it's under the maximum power thing. Whoops. There we go. That's a little easier to read, I think. Okay, so the last thing we need to do is... oh, one other big important thing is doubles. Actually, I don't know if I needed to do that or not. Anyways, I made these doubles because beforehand, if you don't, this 100 million ended up being like 1e plus 0.8. Like, it ended up being a really screwy number. I don't know if it was actually still functioning correctly or not, but better safe than sorry, so I changed it to a double. We also, I realized, don't need this one, because we kind of already filled that in. We could, but we don't need to, as far as... we could use that value, but it's kind of redundant. So the last thing we need to do is right here, right here. So after it sets the value, we need to do or sets the velocity, sorry. We need to do, not a set value, the apply action, on, off, and turn it on. So essentially, what we're doing here, in case it wasn't already obvious, is we calculate the percentage, turn the thing off, set the braking power, calculate the velocity for the rotor in terms of its percentage, set the value, and then apply action, and turn it back on. Sure, set the velocity. This all we can actually get rid of, really. It's not entirely necessary once we get the code running. So, we should be left with... Whoa, my game got super laggy all of a sudden. I don't know what that's about. I'm literally getting like 5 frames per second. What is going on? It can't be just turning the rotor on did that. Well, it is sure not liking something. Maybe it's all the constant updates. Let me turn... Wow, dude, this is bad. This isn't even frame rate, I don't think. This is like in-game physics something. Alright, turn this off. Alright, now turn this off. Alright, so it is moving. Though why it's causing so much lag or frame rate problems, I don't know, because it didn't even do that on my single-player world, my Let's Play. I don't know what that's about. We'll turn it on, run it. Okay, so it's kind of moving, so we need to place some things that draw power. I'm pretty sure gravity generators draw a lot of power. Man, I don't know what's causing the problem, though. It shouldn't be doing this. So if we add that, and then, now granted, you could have it test a bunch of this, but apparently that's causing a lot of lag problems, so we're just going to run it manually, and you'll start to see it spin faster, because the current percentage is 0.1. Actually, hold on. That might be 1%. As far as if we were to actually convert it to a decimal. I don't think mathematically you need to do it, but for reading like what percentage it is, I think you need to do it. Possibly. I don't know. I don't know. What is it at, 1 million? 1, 2, 3, 1, 2, 3. Oh, no, that's 10 million. Alright, so let's add some more, because reasons. Oh, there we go. The current power. 10, so it should be at 10%. So this meter here... Wait a minute. I might not have done this right. 28.28% velocity percentage is 8 out of 30. I have a theory that the math is right, the display is wrong, I think. Gosh, it is so laggy, though. It's probably because of all the gravity generators now at this point. But something about this code, it worked fine on my single player. This particular world is not happy about it, though. 57, so we're at half. So it should be... Okay, so the velocity percentage and the power percentage display is probably wrong. But if you look at this, the current RPMs is 17 and the max is 30, which 15 would be 50% of the current RPMs. And the current power is at 57 of 100. So we are right where we need to be mathematically. It's just displaying incorrectly as to the percentage of how everything should be running. The velocity percentage, I think, might actually be right. No, because velocity percentage is creating it's creating the RPMs that we need. So it is not 17%. It is 17 RPMs, which is 50%. So it's coming out right, it's just displaying on the screen incorrectly, and as you can see, when it actually catches up, the rotor is spinning correctly. It's just causing a heck of a lot of lag for some reason. It did not do that when I did this on my other map. So I don't know exactly what the problem is. I mean, at this point, it's all the gravity engines. I get that. And we're at 81, which 24 should be at about 80%, and it's spinning faster. So that is perfect. I would have to tweak with it to get the display to do right, but I'm not currently planning. Let me know in the comments if you guys would like it to display what's going on. If it is, I will figure out how to work it correctly. The power percentage is just multiplying it by 100, and it will... I could actually fix that. Now I'm not going to do it. It would be fine because it's 81%, so it would be perfectly fine. The velocity percentage would be kind of another ball game. I would have to multiply it by some other value to get it to 100%. But actually, you would have to multiply... Anyways, that's irrelevant. Let me know what you guys think as far as if you... Wow, I can't even move. If you guys would like to see the display, see it display something, let me know. Otherwise, I'm going to call this script done and clean up the code and get rid of the display code and stuff like that. And so if you actually want a reactor to spin, you can do it that way. So I know this was really long, but it was one of those things that as I was doing it, I figured we could actually accomplish it in one go, which we did. So I'm going to let you guys go with that note. So let me know what you all think. In the meantime, I hope you all enjoyed. If you did, leave a like, and I'll see you all next time. Peace.